Welcome back to the lesson series. In the previous video, we had gone through the analysis and verification process. There is of course so much to be tackled in that area, but hopefully I provided you with a good starting point. In case you missed the lesson, you can check it out in the link above. In this lesson, we shall look at different ways to view the analysis results, particularly for bar elements, that is the beams and the columns, and also a brief look at tables. This is perhaps the onset of the most interesting parts concerning design. So let's get to it. So you can view results in this layout, or you can move to the results layout, for example, right here. In this case, if you want to view it from here, let's go to the results menu, begin with the diagram for members. Now this shows us the basic actions within the bar elements and nodes, that is the shear force, the bending moment, the axial force, and also the reactions. So you can use this option to view results for both the bar elements and the nodes. So beginning with this NTM tab, now this gives results specifically for bar elements. Now the forces are oriented to the member local axis. As you can see in the figures shown, that is how the forces are oriented. We have the axial force, that is Fx, then Fy, the shear force in the weaker axis, Fz, that is the shear force in the strong axis. Then the moments, we have the moment in the stronger axis as My, Mz, that is the moment in the weaker axis. Then finally, Mz is the moment in the torsional moment. So selecting an option and applying, for example, we want to perhaps check the moment, My, then applying it. Of course, you have to change the load case. Previously, we had removed or exempted these other simple load cases from having results. So we just remained with ultimate design and serviceability design. So we'll just select that one. So immediately you'll see some graphs. Let me just close this. You'll notice some graphs moving on. Just to view the results, go to parameters. So you can add values and differentiate them. Just to tailor the graphs, like that. So the overall figure is sometimes untidy. And so filtering out certain elements and viewing them separately is a preferable idea. For example, if I were to just close this, then perhaps I wanted to view for the external columns. So I remember earlier we had created some groups in the previous video. So if I just went through stereo columns and selected them, then I decided to edit in new window, like that. Now I can go ahead and apply it. So MZ, and then just make sure the parameters are okay and then apply. Now it's much more clearer, as you can see. This is how the moments are distributed. You can also check out how the shear force is distributed. As you can see, you just remove the moments like that. Then depending on the view you're in, you'll have a legend here to just show you the maximum and the minimum values. If I were to move perhaps to a plane, let's say YZ for example, the values will keep on changing depending on the plane I'm in. So depending on just on these values that are here, or these columns that are here, the maximum is 78 and the minimum is 44. If I were to move perhaps there's no external column there, let's move to the final one. I think that's where we were in. We go back to the first axis. As you can see, the values are changing, but to just continue on like that, have different values there. Again, different values. So the one bad thing about using this diagram for bars, you cannot be able to easily view perhaps different graphs for the different actions simultaneously. As you notice, I love to select one and deselect the other, because if I were to just apply all of them, except this ones perhaps, and check, you see it's very untidy. It will show me the maximum minimum values here, but I can't really check out how they are distributed along the figure or the model. that's it to deal with the NTM, that is for the bar elements. Now moving on, we have the reactions here. Now these reactions are tailored for the supports. So beginning with the first one, on the reactions itself, now this just shows forces at each of the supports based on the global coordinate system, that is the one here. So FZ is automatically the reaction we're looking for example. So it will be dealing with the supports at the bottom here, or those nodes which have support conditions verified or defined. So if I were to just click on this and apply, immediately you notice some arrows here. So I haven't activated descriptions, so if I just do that, I can be able to view the different values. So I can also do the same and check it out in this manner. So these are how the values are distributed: 906, 1529. So if I were to move to another axis, there are no columns here, or rather no supports here. Move to this one. This is the internal part. So we have this very high value here. If I went over to residual forces, now this just shows the sum of forces at each node. It's used as a check for equilibrium of a structure. So it is expected to be 0 unless there is a problem in the model. So it can be used to verify a successful load transfer, for example, as you can see. Moving on to pseudostatic forces. Now these are nodal forces arising from loads indirectly applied to the structure. Now this could be in form of seismic loads or wind loads, or other wind generated loads which are not assigned to any part of the model. As we looked on previously how we are assigning loads to the different elements, now these loads are not assigned in that manner, rather they are externally assigned. So that's it on the diagram for bars. We just close everything, clear it out, head back to the main view. Moving on, we have another option for viewing the results, call it the detailed analysis. And this is similar to the diagrams for members, but just give results for selected bar elements. So these elements could be one or several. If you were to select several elements, for example, you just have to make sure there's some continuity between them. For example, you are selecting a continuous beam or a column from ground to top floor, for example. So for example, let's perhaps first select these columns. So I'll hold control and then just left click on the columns to the last one. Then I go to results, detail analysis. So immediately it will separate out those elements and open them up in a new window. As you can see, just lower this, look at tables later on. Then the same layout for the actions. So if I were to just view the moments and apply them, so essentially it shows me how they're distributed along the length. So in this case, we can be able to view different actions within the elements in a way that they are not superimposed to each other, so it's more tidier. You can even decide all of them. As you can see, everything is separated out and detailed, so there are no ground elastic reactions here. Displacements, there are no displacements, rather they'll be given in the table, but we're not talking about the table right now, so you can just apply those. So you can view how everything is distributed within the elements chosen. So let me just close. Before I close it, I want to uncheck everything. So now and then apply, then just close this. So once you're done, there's another way of checking out the results, and this is perhaps for just a single element. So you can go ahead and just select it. For example, let me try and select a beam. Select this beam here. Once you have it selected, you can use the object properties or the member properties, either by right clicking on object properties, or you can go to results, then properties, member properties. So in this case, this shows all the properties, that is for the section, the material, analysis results, and perhaps if there are any designs done, it gives you the code checks. So beginning from here, we have the geometry, then the section and material properties, then what you're interested in is here. So we can figure out how the moments are distributed. Then if we click on extremes, it just shows us the maximum and minimum values, or rather the critical values. So you can view them, in this case you can only view them individually. So if I were to go to Fx, that's the axial load within the beam, then Fz, the shear force within the beam, as you can see, then Fy, I think this is the shear force in the weak axis, like that. If I go to displacements, so I can say displacements in Z, so this is how the beam is displaced, Z axis. Then you can click on maximum deflections just to check out. So in point, so at this point we have the maximum deflection of minus 1.9 at 0.43. Then you can go to code checks if we had any designs done. So in case you want to print out just the data for this element, you can click on print out. It gives you everything that is required, including the diagrams. So My, Fz and Fx, those are the most critical ones. Then also, in case you've done any designs, it will just give you the results and the code checks. So one last thing before we close, we're going to have a look at the tables function. This is also a good way to just view the results, or rather any kind of data within the project, as long as it is populated. So before you do anything, just want to filter out what we want specifically. For example, we might want to view the results for the staircase beams. So I can go to the selections, pick out the group. We had created this group earlier in the previous video, so staircase beams. Then once you have that selected, you can either go to this icon here for tables, go to the view tab and click on tables. So we want to look at forces. So this mode here, we want to filter out to current selection. That is the current selection here. Then press on OK. So this will just show us the actions within the elements we have selected, and then also the load case. So in case you want to filter out, perhaps you want to change or add another load case. Since we're on this view, you can just go to this select case. Then I want to add another combination, perhaps serviceability also. So as you can see, populates it also. So every member, as you can see, let's just have an illustration here. So this is member 473. It's just showing you all the values of the different load cases. I don't want it to be 1 to 10. I want it to just be not 1 to 10. I just want 9 and 10. 9 and 10, like that. Then you can also filter out the elements, perhaps, but we've already done that. Then if you right click, we can also add other columns. Just right click and add. So depending on the members or the objects we've selected, there are going to be also other values which can be viewed. Perhaps let's try to look at deflections. So member deflections, and then let's try total. Okay, so it will be added on this point. Just try to add something that we can view. Maximum deflections, other member displacements, then apply. As you can see, so it just gives us the values of the displacements or the deflections. So you can also add, depending on what you want, we can add other kinds of data. Moving on, the bottom here, so the values tab, that's where we're in. And this gives values of the different actions acting on perhaps the selection of nodes or members due to the different load cases and combinations. So it combines all the parameters we have filtered out, the members, the nodes, and also the load cases. We move on to the envelope tab. Now this gives the maximum and minimum values of actions acting on the nodes from all the load cases and combinations, as you can see. So it's telling us for member 473 at node 362, case 9, that's where the maximum is. For Fx, that is the axial load, and then the minimum is at 361 at 9, of course, at load case 10, that is the serviceability, then its value is 19. So it goes on like that, gives us just the minimums and the maximums. and also the load case where they are found in. Then going to global extremes. Now this filters out the most critical values of the various actions and the nodes within which they are found. So as you can see, the maximum values for fx, just depending on the selection you've made. Then also the member in which it is found in, and then the node, also the load case. And lastly, going on to info, this just gives us now the filtering data. So we've selected, this is the members we've selected. Then this, of course, yeah, at the bottom here, this is the full list. Then the selection is now the members we have selected to be viewed in the table. Then the load cases. Then the selected number, rather for the members of 10 members. Then load cases 2. So this just gives us the overall information. So generally, there's so much you can do with tables, and we'll be able to cover all of it here. Generally, I've given you just how to look at results for members and nodes. In the next video, hopefully we're going to look at how to understand the analysis results for panels. So see you in the next video.